This is part 2 of the chapter 34 lectures. So we had covered digestion in the mouth and the digestive enzymes produced by the salivary glands. So we'll move on to going through the pathway that food takes. Food is going to move through the mouth into the pharynx, and that is the part where the food is swallowed and enters the esophagus rather than the trachea. Air would go and would enter the trachea, and food and liquid would enter the esophagus when you swallow. So food's going to travel down the esophagus into the into the stomach. I went to the liver, but food's going to enter into the stomach, and then it's going to be mechanically processed there. It's going to be churned and mixed with acid and one digestive enzyme, which is a digestive enzyme for protein. The acid primarily lowers the pH so that the enzyme that digests the protein, it only works at a low pH. So the acid lowers the pH so that enzyme can be activated. And it also helps to kill bacteria that enters with the food that we eat. So after the stomach, food enters into the small intestine, where it is now called chyme, chyme. It's called chyme, and it enters the small intestine, and then secretions from the liver, the gallbladder, and the pancreas enter the small intestine as well. The liver produces bile, the gallbladder stores bile, and so bile is sent into the small intestine. Bile helps to emulsify fat, similar to what dish detergent does. Dish detergent breaks down grease on your dishes into smaller droplets. So the liver produces bile, and the gallbladder releases that bile to emulsify fats, to break fats down into pieces that are easier to manage. And then the pancreas produces digestive enzymes for all the nutrients that we eat. And so that is where most of the nutrients that we eat are digested, is in the small intestine. The large intestine, once the waste enters into the large intestine absorbs water and also has some bacteria that live in the large intestine that help to produce vitamins that we need. And so this process of absorbing water forms feces, and then the feces exit through the rectum and the anus. So here's the notes on everything I just said. The mouth contains 3 pairs of salivary glands: the parotid gland, the submandibular gland. The mandible is the jawbone, so it's below that. And the sublingual gland. Lingual stands for tongue, so the sublingual gland is underneath the tongue. And these glands produce salivary amylase primarily, which digests starch into sugar. And the tongue and the saliva from the salivary glands forms the mixture of food into a ball called a bolus. The bolus is swallowed in the pharynx. There is a structure called the epiglottis, which covers up the opening into the trachea to keep food from going the wrong way. And so it helps to move the food into the esophagus. And there's also a structure that closes off the opening into the nasal passage. That is the soft palate. So when we swallow, there are 3 places that food can go. It can actually go back into the nasal cavity, You may have laughed really hard when you were um, drinking and had your drink come out your nose before. Um, and you may have been talking or laughing while you were eating, and food went down the wrong way, down your windpipe or your trachea. So the soft palate keeps food from going into your nasal cavity, and the epiglottis keeps food from going into your windpipe or your trachea. Um, and this just shows this is the bolus of food being swallowed. Um, this this is the where the bolus is right now is the pharynx, and it's being swallowed into the esophagus. There's the epiglottis that closes over the trachea and prevents the food from going down into the trachea. And then the soft palate, when you swallow, keeps the food from going back up into your nasal cavity. Um, the esophagus has no digestive function. It just simply takes food to the stomach by a process called peristalsis, contraction of smooth muscle. And then the stomach um, has many folds, which, excuse me, those folds flatten out when the stomach is full, but the stomach can actually fill to a volume of 1 liter, which is about half the size of a 2-liter drink. Pepsin is the enzyme produced in the stomach that helps to digest proteins into smaller peptides. And of course, the stomach also produces acid, hydrochloric acid. And the stomach has cells that secrete mucus to protect the stomach from the hydrochloric acid. But once the food leaves the stomach, it's called chyme, and it enters into the duodenum of the small intestine. That's the first segment of the small intestine. So food that is mixed with gastric juices from the stomach. Gastric juices are the combination of food and acid and enzymes and mucus that um, mix together in the stomach. So that forms chyme. And then there is a sphincter, which is a round muscle called this one is called the pyloric sphincter. That controls the entrance of chyme into the small intestine. The first segment that chyme enters into the small intestine is called the duodenum. And this is where the secretions from the liver and the pancreas and the gallbladder mix with the chyme. Bile emulsifies fat, and then from the pancreas, well, I'll show you this first. So this is the gallbladder. So bile is produced in the liver, and it can enter into the gallbladder and be stored there, or it can directly enter into the small intestine. But there is a bile duct that leads from the gallbladder and the liver that connects with the pancreatic duct. And I think once it connects, it's called the hepatopancreatic duct. Sorry, hepatopancreatic duct. And that duct, hepato means liver and pancreatic means pancreas. That duct leads into the duodenum, and that is where um, it mixes with the chyme and begins digestion. The pancreas is an exocrine gland and an endocrine gland. It functions as both. As an exocrine gland, it produces digestive enzymes that enter into the duodenum of the small intestine. Amylase digests starch, trypsin digests protein, and lipase digests fats. And then there are many, many more enzymes that are not listed here. The steps of digestion are shown. First, there's the ingestion of food into the mouth, and then propulsion includes swallowing, and then the peristalsis that moves the bolus into the stomach. Once the stomach is in, once the food is in the stomach, and then especially once it enters into the small intestine, we have chemical digestion that occurs all throughout the small intestine, from the duodenum through the jejunum through the ileum into the large intestine. And then the chemical digestion in the small intestine is accompanied by absorption. Once the food has been digested into smaller nutrients, it is absorbed through the walls of the small intestine into the bloodstream. And then once the waste, the feces, get to the large intestine, the primary component that's absorbed is water to compact the feces. And then mechanical digestion occurs primarily in the mouth by chewing, in the stomach by churning, and in the small intestine by segmentation, which are movements of the intestines we call bowel movements. Let's see. We kind of went through this already, but this is just another um, illustration that helps you understand digestion a little bit better. A little more detail about exactly what is digested where and what's absorbed where. Um, Anything that is lipid soluble that's already digested into small enough particles, such as aspirin, is digested through the walls of the stomach. Um, Carbohydrates, lipids, proteins, and nucleic acids are chemically digested in the small intestine, anything that wasn't digested in the mouth or the stomach. So the small intestine primarily handles chemical digestion. And all of those components that are broken down become nutrients. Peptides are small chains of amino acids, and then amino acids are the building blocks of peptides and proteins. Glucose is a simple sugar, so is fructose. Lipids, small lipids that have been emulsified by bile. Water, minerals, and vitamins. All of these are absorbed into the walls of the small intestine and then into the bloodstream. There's no real chemical digestion in the large intestine except what occurs by bacteria. But ions, water, minerals, vitamins, and some of the molecules produced by the bacteria can be absorbed in the large intestine. The absorption is enhanced in the small intestine by folds. Villi are ridges on the surface of the inside of the small intestine, and microvilli are even more folds in the free surface of the cells that line the small intestine. And all of these folds increase the absorptive area, increase the surface area, so that more nutrients can actually be absorbed. If you just had a small intestine, like if this was a cross section and the inside were smooth, you could absorb nutrients. But if you had a small intestine that was folded, look how much more surface area that is for the absorption of nutrients. Each villus or fold in the small intestinal wall contains blood capillaries and lymphatic capillaries called lacteals. The lacteals primarily handle larger fats, and blood capillaries will absorb all the other nutrients. And I think I'll stop here.